Welcome to the math classroom. This lesson is a continuation on our previous lessons on solving differential equations. In our previous lesson, we looked at what's the exact differential equation. Our lesson today focuses on non-exact differential equation. If it happens that the differential equation I'm looking at, let's say my xy dx plus nxy dy equal to 0 is not exact, how do I go about it? So if it is not exact, what I can do is make it exact. Make it exact. How? So how do I make it exact? So we could do that by multiplying the whole equation by an appropriate factor. So we look for an appropriate, let's say an appropriate factor. Okay, and with this appropriate factor, we multiply times what? Our differential what? Equation. So look for appropriate factor and multiply what? By the differential equation. And this appropriate factor is what we call the integrating what? Factor. Very good. So if our differential equation is not exact, then I can find what? My integrating what? Factor, then multiply by my differential equation to make it what? Exact, and use the procedure in our previous lesson, which the description is found in the link. It's in the description, so you can kindly check that if you haven't seen that video yet. So how do I find my integrating what? Factor. So in finding the integrating factor, one way to look at it, it's finding the factor as a function of what? X. So in finding my factor as a function of x, I have what? I could write 1 over what? N. Then look at, so I have 1 over n. So this is n. Okay. Then find the partial derivative of m with respect to y minus the partial derivative of n with respect to what? X. So my integrating factor here, let's say the integrating factor, it's u of x, is going to be the exponential integral of what? F of x the what? X. So this is the word integrating factor I'm talking about. Let's say IF. And if it's a function of y also, I can write it in a function of y, that is going to be 1 over my m, so that I have the partial derivative of n with respect to x minus my partial derivative of m with respect to y, so that my integrating factor is going to be a function of what? Y. Very good. So that is what? Exponential integral of my function of y dy. Okay, so this is the integrating factor with respect to what? As a function of what? Y. So with this integrating factor, then I multiply that factor by the differential equation given to make it exact. Then I could solve as well. Another way of finding the integrating factor, it's when you have a first order linear equation. So let's say I have a linear equation. So let's say I have the linear equations. Okay, because we could reduce to that form. So let's say a first order. So a first order linear equation in a differential form. Let's say in a differential form can be rewritten as what? A. So in a differential form I have a of x dy plus b of x y, then I have c of what? X. Okay, so for a linear differential equation I can write it what? In this form. So this is a function of x, this is also a function of x, and this is also what? A function of what? X. The other way round, then it will be what? Different. So in the standard form, so this is the differential form. If it was in the standard form, let's say the standard form, then I could have the first derivative dy dx plus, let's say, p of x y to be equal to what? K of what? X. Okay, so that if I'm able to write my differential form in the standard form as this, then I could find my integrating factor. So my integrating factor, let's say the u I was using is going to be the exponential. So e exponents the integral of what? P of x dx. So you can look at it this way as well. So that if you know the integrating factor, you could multiply through by what? The differential equation. So if I have the differential, so let's look at this form. If I have dy dx plus 3 over x y to be equal to what? 5 what? X. We want to find the integrating factor here. So what do you realize? You realize that dy dx, it's that, then add p of x. So this function should be a function of x, and this should also be a function of x. So you realize that I have this, then I have that as well. Okay, so you realize that this is actually in a standard form. So from here, you notice that our p of x here, it's equal to what? 3 over what? X. So that if I want to find the integrating what? Factor, what do I have? the integrating factor is going to be u exponent integral p of x d what? dx. That is my u from here. So you realize that u is going to be the exponential 3 over x integral dx. And if you simplify, what do you have? If you simplify, you realize that you have, from here I have 3 is a constant, so I can bring 3 out, so that 1, if I integrate 1 over x, what do I have? Ln x, that's the natural log. So let's say I have log x. Okay, so you can write it from indices. I can write e to be equal to log of what? X what? Cube. So you realize that this cancels what? That. So if it cancels, then what do I have? I have what? X what? Cube. So my integrating factor here, you realize that the integrating factor here is what? X what? Cube. So since I know the integrating factor, my IF, it's x cubed. What do I do? To make the equation exact, I multiply through by the integrating factor. So we multiply through by what? X what? Cube. Why don't you pause the video and do it so now? Okay, very good. So if you multiply through, what do you have? You realize that you have x cubed dy dx plus 3x squared, because it is going to be what? Times what? Here is going to be, you are going to have times what? X cubed here. So this x will cancel one of that. So you have 3x squared to be equal to, so this is going to be times x cubed. So in the 6, 1 plus 3 is 4. So I have 5x to the power what? 4. So now this differential equation is what? Exact. So if it is exact, so exact ODE here, you can actually check if it is exact by writing it in the differential form and finding what. So if it is exact, we say the partial derivative of m with respect to y should be equal to the partial derivative of n with respect to what? X. So why don't you check if it is exact and give your comments in the comment section, and also find the solution to this differential equation. Our next lesson will take more worked examples on non-exact differential equation, or what we are going to call the integrating what? Factor. Thank you. Bye.